So we're starting integration by parts, and integration by parts is the integral of our product rule. So we end up with this nice little formula here. It's the integral of u dv, which equal to uv minus the integral of v du. And these variables make it very nice to use this formula because it looks a lot nicer than this. But we need to figure out where this comes from before we start applying it. So all we're going to do is basically take our product rule and take the integral of both sides. So we're going to integrate our product rule. And you may notice that I've actually switched the g and the f so that we have g prime first. It doesn't matter. So it works the same way. So we end up with fg equals, and then this would become the integral of f g prime dx plus the integral of g f prime dx. So now if you go down here, this is what we're looking for. So this one needs to stay put. This one needs to stay put. See, they're on opposite sides of each other. And that one just needs to move over. So if we rewrite it, we get the integral of f g prime dx equals fg minus the integral of g f prime dx. So all I did was move that one over. And there it is. There's our nice little formula that we can use for integration by parts. So now what we have is an integral with a function and a derivative. And that's what we're going to be using it for. And so now if we do a quick little swap, because these letters are fine, it works great the way it is, but we want to have this a little bit nicer. So it's not just two functions, but just a plain old letter like this. So if we take and make our u equal to f, our v equal to g, then that would give us this. And then if we plug them all in, we end up with this. And you can do that quickly. See, u is f. And then, where is it here? dv is g prime dx right there. And then we get f and g. Well, that is just u and v right there. And then we have the integral of g f prime dx. So f prime right there is du. So f prime dx is du. And then our g is just our v. So it looks weird in this formula. It looks complicated, but it really isn't. You're going to like it a lot. And we're going to go through a bunch of videos with a bunch of different methods and tricks to use. But we're going to be using just plain old that little formula there. So what that means is we're starting here with this integral. So we need to pick a u and a dv to start. Now the main focus is the u. You can even use the dv, but what I like to do is think about the u. And we have a little method here that someone came up with. So it's logarithms go first, and then inverses, algebraic, trigonometric, and exponential. This is your u picking. So what's going to happen is you're going to take the derivative of the u. So we want to make sure that we pick our u to actually make it simpler. So logarithms, and then inverse, and then algebraic. It's the way we want to work. So if we look at our first one, we have x plus 1, and we have e to the x. And the more you do of these, the more you won't even need this anymore. You'll just know, oh, I picked this one. So if you look down our list, our exponential is down here. Our algebraic, which is the x plus 1, our polynomial, is right there. So we want to start with the polynomial. So we're going to pick this right here. Well, that was horrible. Let's try that again. That's our u. And then we're going to pick this one to be our dv. So that's what we're using our integral for. So it's the integral of u dv is equal to uv minus the integral of v du. And when we write these out, it's a very quick little cross multiply thing, and you'll see it. All right. So our u is x plus 1, and our dv is e to the x dx. So this one we take the derivative, and this one we take the integral. So what we're doing here is we're moving this one forward. So we're converting the u into a du, and then we're going to take the dv and turn it back into a v. So this one we want to have as v equals, and this one we want to have as du equals, so that we can plug it all in. So the derivative of u, just like we would normally do our normal u substitution, which is why we use it that way, this would be 1 dx. And then this one is the integral now. So we're integrating both sides, and so we end up with e to the x. And then I always like to take the v and check it. So the derivative of e to the x is e to the x. Checks perfectly. Now, if you look at our formula, it's uv. See that little cross multiply there? So this one right here goes first. So that's what we're going to start with. Our u is x plus 1 times e to the x. So it really is just a multiplying of those two. That's uv. And then we move on to the minus. And then we have our integral. And then it's v du. So if you look at it, it's just these two now together. Right here, these two. So we just take that one right here, e to the x, and the 1 dx, these together, and we put them together. So it's e to the x dx. See, just like that. So we replace the du with dx. replace the v with e to the x. So the way you do it is just multiply those together. That's the first one, minus the integral of the last two. All right, now we have our nice little formula. So we end up with x plus 1 e to the x minus integral of e to the x is e to the x, and then we put plus c. And just like we've done before, we want to put the e to the x together. So this is x plus 1 minus 1 plus c. And so we end up with x e to the x plus c. And there you have it. There is our integration by parts. Now, we always want to take and check this to make sure that it is correct. So if we do the derivative of this, we would end up with 1 e to the x plus, and then it would be x e to the x, and then the c would disappear. And so we factor out the e to the x, and we get 1 plus x. So it checks perfectly up there, see? Okay. So let's try this again. So same thing will happen. We're going to pick the algebraic first, right? No, what we have here is a logarithm. So that's the one that you want to pick. Because what happens is if you take the derivative of a logarithm, you can find it. We're not doing the integral of a logarithm. So logarithms need to go first. So this is our u, and then this one and this one together will be our dv. So again, you're just picking your u and your dv first. That's what we want to always pick first. So our u here, let me give it a little more room, is natural log of x. And our dv would be 3x squared dx. This way, when you take the derivative, we get 1 over x, right? So we end up with du 1 over x dx. The integral over here now is just v equals 3 over 3x cubed. And so that cancels, giving us just plain old x cubed. See, it's still nice. So now we'll take these two and multiply them. All right, I'm going to write out the formula again. Let's zoom in now. So it's the integral of u dv is equal to uv minus the integral of v du. Okay, so we'll start with the red. So u is ln of x, and v is x cubed, minus, and then now these two together. So we take that one and that one. So you can see it's x cubed integral, green, x cubed 1 over x dx. Okay, nice clean little substitution. And we end up with x cubed ln of x minus, and then this is now the integral of x squared dx. See, our polynomials are good derivative or integral. So we want to always make sure we pick the u. That makes it nicer. Okay. And if you mess them up, you pick them incorrectly, then all you do is go back and switch them. And so if you had picked 3x cubed and ln of x, you would have gone, oh, oops, let me switch them. And then we go that way. All right, so this becomes 1/3 x cubed plus c. And then since they both have an x cubed and a 1/3, I'm going to factor that out. You don't have to, but I want to. And then this becomes 3 ln of x minus 1 plus c. Either of those are fine, though, for your integral. Just always make sure you check it. So the 1/3 would cancel, giving us ln of x. The 1/3 x cubed is here. And then I still have to check it because, well, we want to make sure it's correct. So we're going to take the derivative real quick and make sure it is 3x squared ln of x. So if we do x cubed ln of x minus 1/3 x cubed plus c, we take our derivative, we get 3x squared ln of x plus x cubed 1 over x minus x squared. So this is 3x squared ln of x plus x squared minus x squared. And those cancel, and we get 3x squared ln of x. It checks perfectly. Everything's good. So this is integration by parts. It's just something you want to try. So when you look at it and you go, okay, well, u substitution is not working. I can't use any other methods. Let me try integration by parts. And so you pick one of them to be u, one of them to be dv. And again, picking your u, you want to go from here. So in the next videos, there'll be a lot of little tricks to get through it. So we're going to talk about all the different methods that we can use to apply this. And then we'll also get into the tabular method. Thank you.